So, hello everyone. Maybe we can start and the other will join us later. So, good afternoon, everyone. I'm delighted to welcome you to today's webinar on the critical topic of asset management. In an ever-evolving business landscape, effectively managing and optimizing your asset is paramount to achieving sustainable growth and maintaining a competitive edge. For this session, we'll be delving into some key areas, starting with the establishment of national database, the backbone of any successful asset management initiative. We will explore the intricacies of data digitization, and the transformation of raw information into actionable insights. In addition, we'll be uncovering the untapped potential of historical weather data and scientific literature, demonstrating how these invaluable resources can enhance your asset management strategies. We will conclude our session with a compelling case study showcasing real-world application and the tangible impact of implement these strategies. Firstly, I would like to introduce our speakers. So our first speaker will be Julien Saïd from RTE. Graduating from the École Centrale de Lyon, he studied the aging of overhead conductor for transmission lines during his PhD in material and mechanical science at the LTDS lab in Lyon. He then joined RTE as a research engineer to study how to conciliate mechanics and modeling into asset management. Julien will be following by his colleague Maxime Gueguin from Eurobios. As well as a degree in civil engineering, he obtained a doctorate from École nationale des ponts et chaussées in structural mechanics and materials. He managed the relation between Eurobios and its partners. He is also the author of multiple scientific publications in international journals. Then our last speaker will be Julien Chazot from RTE International. Julien holds a science degree from the INSA of Lyon, as well as an engineering degree in HV electrical networks from the Technical Institute of Buenos Aires. Before joining RTE in 2013 as a real-time operator in Nancy, then as a regional load dispatch center team manager in Lyon, he worked as a project manager for the development of wind farm. As a full-time project manager for RTE International since 2022, he has been in charge of various projects in relation to asset management, maintenance optimization, and live working all around the world. So without further ado, let's dive into our first presentation. Julien Saïd, the floor is yours.
All right, thank you very much. Well, I still see that a lot of people are connecting. Maybe I wait maybe 30 more seconds before going into it, if that's okay, and then I start.
Yes, of course, we will wait a bit.
Okay. Well, I think that's good. Well, thank you, Camille, for this kind of introduction. So, as you said, I am Julien Saïd, and I work at RTE as a research engineer within our R&D R&D department. So maybe before going straight into the subject of data management and how it can be related to asset management, I will just introduce or reintroduce RTE and its R&D department. So now just a few figures about us. So RTE is a TSO in charge of the French power grid, and we are maintaining and operating one of the largest grid in Western Europe, working with more than 100,000 kilometers of power lines. We have, well, it has almost 10,000 employees and working with an annual revenue of up to 5 billion euros every year. So, well, most of this revenue, of course, goes to mainly maintenance, deployment, and operation. But what I want insist in the part of this revenue I want to insist on right now is the part that goes to research and development. So within our R&D, dedicated R&D department, we have 7 major R&D programs, working with about 40 million euros of annual budget. Up to 200 people are working there currently. And we have a lot of external partners, a lot of external partnerships, among which I may mention we are working with companies, universities, labs, etc. So I will maybe tell a few more words about our 7 R&D programs. So we have, for instance, I won't go too much into the details, but I can mention that we have one regarding perspective on grid equipment, new ways about how to operate our electrical system regarding the future evolution within the next decades. Same with regarding the system stability, knowing that there will be a lot of changes in the near future. Again, prospective, but this time more focused about markets and grid evolution, as well as a program that will focus more about the environment and promoting promoting as well as sustainability and the interaction with our society. Of course, a program where I'm currently working about asset management that I'll go into further details in the next slide. And one last program about more transversal R&D. So as I said, I am currently working in the asset management program. So I will detail a bit more about what we do here within the asset management team. So we are working on a lot of different topics, a lot of different subjects, and I only showing here four of them. I may start with, for instance, one about digital twin of our grid regarding all the data we are collecting and monitoring in order to help us with the dispatch and control room. For instance, here to illustrate that, you can see on the left picture visual digital twin of our future control room that we will be using for dispatching, among other things. Another program regarding still some kind of digital twin, I may say, about how to automate the automation of inspection and monitoring devices in order to improve the way we do maintenance of our grid. Here, for instance, you can see LiDAR. What we do is LiDAR measurements of our grid. We also have a big project regarding a simulator of asset management policies that can be quite helpful to help us to assess the long-term consequences of our current and future policies regarding asset management, so we can look into what will be the consequences regarding the future costs within the 4 or 5 next decades, and also the evolution of pool of assets. And finally, and this is what I am myself specifically working on, is about physical understanding and physical modeling of the behavior of our assets, especially focused on the assets of power lines, overhead power lines, sorry, even though we are now starting to expand our scope. Okay, so that's all for this introduction about RTE, and now a bit more into the subject of data. This slide is mainly here to emphasize on why it is so important to work on data management and data quality, and overall why it can be so difficult at times. So I'm relying here on the history of the French grid for my story, but I'm guessing that a lot of other TSOs, for instance, in other countries, are in a similar position with similar histories. So the first input of data that we have comes actually from the early 1900s, with the first transmission lines operated by the first energy suppliers. And each of these suppliers had their own pool of data with their own format and their own pool of assets. And then with the First World War, the first fusion between distribution and transmission networks happened to follow the beginning of the military-related production. So at this time, they had been the first merging of pool of data and modification of data. that may bring some first errors and mismatches, etc., things like that. The next big step is after the Second World War, now with the creation of EDF, which is for Électricité de France, which was a company created to gather most of French production means, distribution, and transmission networks. So then again, they had been, they had been a lot of merging and harmonization between all the previous pools of data that were to create the first national. Then, a bit later, in the early 2000s, the creation of RTE as a French unique TSO. And within the last 2 decades, there have been a lot of changes regarding data, especially with the internet and a lot of digitalization of our data, online storage, online clouds, and things like that. So at the end, when you look at a century of data collection and recording, of course, you can guess that you have to work on your data to make sure that they are reliable and overall usable for other applications. Here, this slide is to illustrate the incoming challenges that we are facing regarding asset management, focusing on the example of overhead power lines, and especially overhead conductors. This is the age histogram of all of our overhead conductors we have on our grid. So currently, the policies that we have regarding conductors are to replace them after 85 years of service. So if you look at this histogram, you can see that for now we have to deal with, let's say, about 500 kilometers of lines every year. But looking at this, you can also see that in maybe 10 to 15 years, then this number will drastically increase and bringing, of course, a pretty big investment cost spike. So, of course, to deal with that, we will need, well, it will require more money. But our mission is also to try to reduce this spike by working into that and try to propose new solution and innovation, maybe, for instance, to focus on which areas are more critical or things like that. Okay, so earlier I talked about all the history of data collection that we may have here in France, but I'm guessing the same everywhere else. So this is another example of the actual sources of data that we are dealing with. So from internal sources, well, one of the obvious ones is about operational data, so the power laws, especially the history of power laws that we have that went through our lines within the last maybe 50 years or so. We also have a lot of observation data, mainly for maintenance maintenance processes, especially defect observation, and we keep records of the failure occurrences that we have on our grid, as well as many means of real-time monitoring. Then there also is, of course, design parameters. Well, most of them should be digitalized by them, but I'm guessing a lot of them are usually in all the archives, maybe on papers or things like that. But they can be really useful data, useful information, especially if you want to do some physical modeling and things like that. But of course, this is not the only application. And finally, we also do on our grid some non-destructive testing to try to assess the level of damage after a certain age for a lot of our spans. Then we also have some external sources of data, starting with the biggest one, which would be the historical weather data, collecting, for instance, the history of winds we have, the lightning strikes, the hurricanes, things like that, that can be also pretty informative. And then finally, I may mention that the scientific literature can be pretty helpful, especially if you want to characterize the behavior of your assets, or at least some materials of your assets, following by other dedicated studies that we also have to try to dig more into the characterization of our assets. And finally, this will be my last slide, is about how you can also use all of this data that you collected, and I spent some time to describe earlier. So once you're comfortable with your data, you can conduct survival analysis. You can also do, of course, what we do about fatigue and lifetime predictions. I talked about non-destructive testing. That's also required to do some damage assessment through signal processing of all this data you're collecting. I have talked about the physical modeling, but not only regarding fatigue and lifetime predictions, but it can be also efficient to just look at the monotonic behavior or vibration performances or this kind of stuff. And finally, I mentioned the dynamic line rate to improve the way you are using your assets and the way you are operating your whole system. Okay, so that's all for me. I thank you, and I will leave the floor to my colleague Maxime.
Yeah, thank you, Julien. I will share my screen. Please tell me if it's good for you, Julien. So yeah, as we said, we are working. Eurobios is working with RTE since 2016 on this kind of topics, asset management, and I will share with you some of our story. But first, I will try to illustrate what are the challenges for managing an asset over time. So if you are dealing with asset management, you know that you will have some failure on your network, and you will need to see which are the main reason for this failure. So at the early ages, you will have installation defects because you don't control everything when you are building your asset. And what you can do when you are an asset manager to improve that, you can do some training. Maybe you will use another design for your system. But yeah, it's like after this, you may face a design issue for the asset. So maybe it was a good installation, but maybe at the wrong place. And you have vibration for overline conductors, for example. So if you are asset manager, you will try to put some protective device, maybe with dampers or things like this. But when you are dealing with a design issue, you may want to change your designing rules over time. It's a good thing. One of the reason for failure is also extreme events. You don't control this, and usually it can be seen as constant during your life. But here, because we are facing climate changing and maybe the network is depending on that, you can see that that asset in 2023 are not dealing with the same environmental stress than in 1950, for example. So for this, you will have maintenance operation, of course, and you may want to prioritize them. You may also want to do some predictive maintenance, which is forecasting. You want to do something before it happens, and you may want to see dealing with extreme events if your network will be, let's say, resilient. That's another part of the reason for failure. And at the end of the day, you will have aging. We start with this with RTE. I will explain this. And when you are dealing with with aging, you can do some non-destructive tests. That's what RTE is doing. You may want to prioritize your refurbishment because you will need to change your assets after, let's say, 85 years. And you also want to do some forecasting to know which remaining life you have for your asset. But when you are dealing with aging, you can also rethink the way of designing your system. So that's what it's the starting point of seeing asset management is this. But with RTE, we once again we were dealing first with aging and now with every kind of reason for failure. we start by wanting to do some forecasting and knowing which part of the network it's preferred to replace before another part of the network. It's forecasting. And for this, RTE wanted to have some, not a black box, so to put the decision dealing with an open modeling of the network. And we worked with physical modeling, thermomechanics, fatigue, vibration, free structure interaction, and so on. But it was the first 2 years of the project. And after this, you want to use this with real data. So you will need to use your database, your every database you have in your company. But for us, it was important to have the asset database and a monitoring database. So when you do this, you may face some issues, and I will talk about this in a minute. But you want to have a model, a data model, which is clear for you and which is reliable. And also, RTE wanted to take some decision for asset management with diagnostic, with non-destructive test. And when you do this, you need to put some diagnosis on your data. And then maybe you will use as RTE some service provider for this. And it's important to know which signal processing is done on your non-destructive test. So let's talk more about this. In few words, in terms of data, you will have, when you are doing, for example, non-destructive test, you will have some data with different format. It's not the same to have the pictures, to have the report, and to have the raw signal. So you may want to put some standards with your service provider to make sure that you know that it's a good asset identification, you know it's this one, and you know where the raw signal is. And maybe you will have signal processing, which is one version a year, and a year later it's another version. You want to do this again with the same raw signals, especially when you want to do some health monitoring of your assets. So it's really important, and we try to, and we reach to our goal on this with RTE. The other part of the problem, once again, is the monitoring of your asset over time. So for this, you will have a network which is not homogeneous. You have some assets, you have some span, you have some, let's say, some components which are related to the span, to the pylons, and so on. And you need to think the model, and you need to have a data model, which is, let's say, entity relationship model, to make sure that this pylon is related to this span, and so on. And at the end of the day, when you are an asset manager, you want to see what is your database, and you will use some interface. For example, we have this one here, and maybe you want to relate this to, let's say, some location of your asset, and know if it's using, if it's in a field, if it's in an urban area, and so on. So you want to use also the open data that you have, let's say OpenStreetMap and things like this, or other kind of geographical information system. So it's also part of your job as an asset manager, and it's really important for the rest of our vision of asset management, which is the forecasting. And for the forecasting, once again, Julien was pretty clear about this. You have some observation, it's your target. You want to predict which asset will have the next defects, for example, or which part of your network is more likely to have the defects. So you will use this target. You will, as as an input, and also some explicative features like design parameters and environmental data, wind, for example, which is one thing that we use. After this, you may want to use some machine learning processing. So the algorithms are well known now, but you will need to take the right algorithm to deal with your problem, and it's a dialogue between the expert of the modeling and the subject matter experts. And at the end of the day, what we are doing with RTE, you may have a map, let's say an heat map on the assets at risk, or you may want to, you will do some survival analysis and say for this kind of asset, I have this remaining life. It's really a thing that you can do now if you have data, and if you don't have enough data, you may want to reinforce this with physical modeling to do some extrapolation, for example. So it's a part of the things that I'm not showing today, but it's really important. And of course, there is a big picture of this. So if I go left once again, you have the dashboarding. It's really important when you are an asset manager to have some pretty clear dashboard to improve your decision making on assets. But you want to face this, you want to put this with your data, and you need to make sure that you have a good quality of your data and that you have, let's say, access to your data, and it's well documented, and you will have access to the data at every time. So it's really important, and that's what we have done with RTE. And on the left, you have the consolidation part, because maybe you will have some data which are not really available, or you will face some issues with missing data. It's a thing that you may have, and you also want to check the let's say if the data is good at any time. So you may want to use some LiDAR technology and so on, and we work on this. But unfortunately, today I don't have the time to talk about this in details, but it's really a good part of the work that we have done with RTE. So to sum up, if I want to show which offer we can have to help asset managers, you have the data governance. It's really important. It's important to have a data quality, and Julien Chazot will talk about this in a minute. You may want to also to deploy this data in every department of your company, and it's a job itself. And you also have other offer related to what we have done with RTE. So on top left, you have some tools to help with design and refurbishment projects. For example, as I said, if you want to put some dampers on your span, we design tools on this, and the same for exceptional climatic events, especially on pylon. On the bottom left, you may want at every time have a health status of your network, and saying with data and physics, can I say which asset is at risk? And finally, the bottom right, you have the daily maintenance matter. You may want to do some targeted inspection on your network, and using the kind of algorithms that we use can be helpful on this. And once again, if you want to do some diagnosis on your assets, you want to interpret to the signal, the raw signal, and to say this asset is in a good health, and this one I'm not sure. So I will put more effort to make sure it's a good asset. So that's our way of seeing what we have done with RTE and how it can be used in other contexts. But now I will let the floor to Julien Chazot.
Sorry for the delay. Can you see the presentation, Maxime, Julien? Okay.
Yes.
Thank you. Well, as far as I'm working for RT International, we have the opportunity to meet other TSOs or transmission asset owners and have discussions about IT solutions for asset management. I wanted to share with you some feedback from, let's say, the market that we have the opportunity to get more information about. Our vision, first, just to share it with you, it's pretty clear by RT. As clearly explained, Julien, we have the peak of investment that are going to come from the line's renewal. So we had to develop other solutions, and we decided to invest into IT solutions and use of data for asset investment decisions. It's pretty simple because it's longer to build a new line or new substation than to develop new tools. And we are convinced that you can get better performance from your assets using the return of experience, the software, and the data coming from your assets. That's our deep thinking. And our job in RT International is both to take the temperature of the best international practices, but also to provide some services tailor-made for other countries. So we will detail a bit further how the expertise that we have in our research and development can be useful maybe for other countries if they wish. We believe that we can cut in three, let's say the maturity, the stage of development for IT systems dedicated to asset management. It almost always begins with a CMMS system. You must have a clear vision of what your assets are, how much they cost, where they are located, when it has been manufactured, what kind of operations you've been doing on them. So all those basic data, we call it like asset database, which is the first big foundation of the system. The asset database here, or digital twin, is one of the fundamental when you want to get more performance from your assets. This will allow you to track your outages, your operations, your maintenance task, pretty much everything. And by the way, it's pretty useful. There is a lot of on-shelf software that can help you to do the schedules for technicians. Then you record your work orders with many data from your interventions. This is clearly the most operational tool, but it's at the same time it provides you performance for dealing with your operational resources. But it has some other effect, which is getting some data from your interventions. That means when you go doing some measurements on a transformer, all the data you get, for example, for oil analysis, then you will record it for the second step. Second step would be when you start to have good description of your assets and data from your interventions. Could be, it's a proposal, to start capitalizing on key data from your assets. It could be, as said Julien, the non-destructive testing for your lines, the drone inspection, results. It can be pretty much everything that comes from maintenance. All those data number of operations from onload tap changer, load race, some triggers, everything then can start to be useful. We believe from those data, from the CMMS, we can start to work on life history of assets, health index, or start to do some corrective plans. If you got some circuit breaker, I wish it won't happen, but exploding or whatever, then you are able to analyze the cause, the root causes of that, and to deploy some corrective plan at the global scale of the company. So this level 2 scale stage is very important to adapt your strategy, mainly for preventive, if you want to switch from age-based maybe to condition-based or reliability-based maintenance. You will be able to do it with the CMMS and with this asset performance management database. So if you want to adapt your strategy, here comes the use of data. You also can optimize some schedules and do some generic corrective plans on your assets. This would be maybe the second stage. The third stage is the one that's been described by Julien. The example, of aging lines. Lines has, like for many other countries, are starting to get pretty old, maybe 60, 70 years old for some of them. Then, even if you take the best maintenance strategies and the best decisions, you have to anticipate all your investments. Here comes maybe the third part, which is the asset investment planning software or database. This will help you to take the good decisions in terms of replacing, maintaining, or anticipating your peaks, investment peaks for OPEX and CAPEX. We believe this is at the strategic level because you can start to make medium and long-term planning for investments. Basically, from the data from your asset description, from your maintenance operations, from all your corrective policies and everything, you're then able to do the modelization of the incoming replacements that you will have to do with the current maintenance policies you have. That's exactly the same simulation that showed Julien a bit before. After stage 2, optimizing all your maintenance policies, you maybe want to have a more strategic vision of what will be your budget. You also can choose to target and to change your full strategy. For example, we had a corrosion plan in France. You can see the maps here below. We decided to change everything, but on all the region close to the sea. We decided, thanks to the data, to determine all the assets that should be maintained differently. Let's say it's true for insulators, for towers painting, and we believe with this change of this adaptive and risk-based strategy, or at least risk-informed strategy, because you know the risk thanks to the data. We believe that we've been able to save many money by changing our painting strategy for towers. So this is there's some concrete benefits you can get from using data at a bigger scale and from long term. So here is the illustration maybe of the 3 stages if we have to start somewhere. First, the CMMS for starting to work on the asset database. That is something that clearly we can provide with Eurobios or our experts from RTE. This is the idea of having the digital twin of the network to track and monitor all the activities to reduce the cost also with maintenance interventions. When you got enough data, you can start to work on the performance of your assets. Here comes the dynamic line rating, as said Julien. Here comes also the maintenance policy that you can adapt to get the maximum cost benefit risk for your maintenance strategy. And if you have all those 2 first floors, then you can get very interesting and very high benefits from risk-driven decisions. I was talking about the painting. We are talking about several millions of euros in maybe 30 years. So asset investment planning connected to other data really can allow a lot of benefits because you take your decisions of investments with a vision and with a risk-driven decisions. So this comes from operational level to very strategic level. And that's the reason the reason we wanted to set up this webinar is because we believe that we can provide tailor-made services or at least to share our experience. Maybe firstly for asset database and IT urbanism, we used to provide maybe preliminary studies of IT urbanism and database just to assess and maybe to advise asset management systems or to assess the maturity and see with the client what possibilities are to be developed. We also can provide, of course, some gap analysis or roadmap for implementing database, asset description database with a vision of all the data that will be useful afterwards. We also can go on the subject, which is very important for energy transition. When you want to develop your grid, you have to take several outages. And with the very intense expectations for energy transition, more and more outage are needed. So if you got better management of your work orders and everything, you will be able to perform more operations and new substations and connect new clients and everything. For us, this is very important part of IT urbanism. When it comes to using data for asset management, we also can provide some services. We can try to work with the client to improve the value of the global knowledge with asset management because it comes, as we saw, from the operational level when you write all the data from your maintenance operation in the system to high level management and risk driven decisions. We also can get into the topic of open source libraries. Relife is a tool it's a library, Python library that is open source and that can very much help you to make simulations about aging of your assets, mainly conductors, circuit breakers, some key assets. So it will provide you some simulations for the optimal trigger for changing the assets or starting to go for some specific maintenance. So we also can work on that. We also can work on the existing baseline on work maybe on the IT development or implementation of specific asset management technologies like drone inspections, conductors, non-destructive testing, the robot that showed Julia. But we believe this has to be linked with all the IT systems. All those technologies, they get the higher benefits if we are able to use the data that they can provide. Once again, feel free to ask questions in the question and answer section. Feel free to contact us. We are always glad to exchange with our friends or peers as a TSO. So feel free to ask questions. Once again, thank you for this webinar. Feel free to ask questions and feel free to contact us for any request, any topic you would like to engage with us. That would be a pleasure to have such a conversation with you about asset management. Thank you for everything.
Thank you, Julien, and thank you, Maxime, for this amazing presentation. So as Julien said, feel free to send us a question in our Q&R area. So I think we receive a few questions. I will publish them as soon as we reply to the question. So the first one is we have several databases. So how we have just one?
Maybe we can start with a question we have from Abdul, which is what is the best way to set a threshold of asset life at the aging stage of an asset? So that's related to the last slide shown by the other Julien actually. He talked about real life, which is a good example on how to answer that kind of tricky question, I may say. So the big thing is you actually need data to be able to answer that. And the two main types of data would be, first, how to assess the survival the survival law on when your assets will fail. That's the first thing. And the other thing is basically the cost of maintenance and the cost of replacement when you have a failure. If you have enough data on both sides, then you can use the Python library called relife, which can give you the optimal replacement age. So that's one way to do it. And when you don't have enough data, well, the thing is you have to invest in collecting your data and to how to assess the cost and things like that. So I hope that's first good answer on that.
And maybe to complete your answer, when you don't have enough data, but you have still some data, you may want to use some physical model with it's combined with the real life approach to answer to this question. But it's a good way to combine this type of modeling.
Yeah, but because of course the sooner will be the better, but still you won't change it too early in the stage of life of your asset. So you want to use it as long as possible. Then, the next question about when you have several databases. So how can we just have one database?
Yeah, I think the answer for this, and maybe Julien Chazot will complete this. The answer for this is it's important to have some clean databases, several databases. It's not really a problem, but you want to make sure that you have the right link between them, and you can once again identify your asset between the different databases. So this kind of approach is really important. And also, maybe you will have some databases with different data quality. And this is another story, because you want to work with your reliable data first, and then you put some other data related to this. And it was quite a work with RTE, not with the projects that we have together, but before that, to make sure that you have this kind of asset database which is reliable, but you want to make sure it's good in over time. But maybe Julien Chazot has some example on this kind of several databases approach. But once again, the important thing is to have a data model. It's the starting point. You want to make sure that you have a good link between your data.
Yes, I'm about to share one slide. Okay. Yes, that's for me, that's a cornerstone, because as we said, the asset database description has to be taught for having multiple use. It must not only be used to calculate, aging, failure rate and everything. We believe at the scale of TSO that we must get every data not in the same database, but at least communicating with key database. We in RTE, for example, our asset database is linked to the future asset database for people who are doing master plans, planning studies. We, of course, link it with the work orders schedule to be able to get all the information from the maintenance interventions, oil measurements, non-destructive testing, pretty much every data that we want to attach to the asset database. When you do inspection, drone inspections, substation visits, you want to get all the intervention requests to be treated. Then you are able to prioritize all the intervention requests and to start to have a risk-driven approach for your curative maintenance. We believe also you can connect all the faults, the trippings, the SID, SIFI to the asset database. So that is precisely why we propose to assess the IT systems, IT urbanism of the TSO. We already made that for some clients. Every time it's very rich because we, of course, are able to question the way we do, but we are able to provide the big picture of IT urbanism and to provide some assessment of that. We believe there is on-shelf tools to use those databases. For CMMS, there is of course IBM, there is SAP, there is Hexagon, many of those that work. But what we think we are able to do is to assess and to be technical advisor as a TSO for how to build the asset database for getting the maximum benefits from that, from the data that it will be linked to. It's the kind of thing we believe we can provide with Maxime and our experts. So it's one unique database communicating with many others, to answer the question.
Okay, thank you, Julien. So we have more question now. I will start with in the order. So did RTE done some pilot first? So yes, we tried some to test our method and modelings on some small areas. When we have we can actually have access to some data to confront our results. So there are a lot of things, different things that we can confront. For instance, if you only work on defect observation, then we can directly apply that on the entire grid and compare it with what you can actually see. While for more physical modeling, then we cannot directly compare to the entire grid at first, but we have in this case experiments in labs or things like that. But then this is kind of related to one other question I saw, which is, what kind of transmission system faults are possible to be predicted using machine learning models? Well, that's a good thing about machine learning is as long as you have data about one phenomena, then you can predict it. Yes. So if you have actually a lot of, I hope not for you, but if you have a lot of failures on your grid, then you'll be able to train your machine learning algorithm on that. If you have other kind of informations or observation from your grid, for instance, strand failures, things that we often observe, like more often than failures, hopefully, then you can train other kind of models to have to be able to predict them according to the environment. And by that, I mean like the wind, the location, is it close to the seas or things like that. If you have access to all of that, then your model will be able to predict the occurrence of this specific fault.
Yeah, and maybe it's good to say that when you want to use the full picture of our approach and using physical modeling and data, you may want to have, let's say, a tool to predict and to model the fault over time with simulation. And for this, you need to work on this. For corrosion, you will need to have a model for corrosion and so on. And it's good to say that RTE in our project is in the thinking of having open tools. And for example, for the fatigue problem, let's say the cut strands Julien talked about, the tools are opened and they want to be used on other data than RTO's data. So it's a good thing. But if you have other faults, you may need to develop some physical modeling if you don't have it. It's the point of this approach.
Yes. So the next question is regarding the future generation means like wind and solar and things like that, and how do we intend to do the assets management for this? Well, in that case, you don't have really data, especially if it's not in production yet. And in that case, then you have to prepare the collection of data, meaning you have to set up the right databases that will be able to collect all of your data along the future years of operation. And this is actually a really key point for future asset management. You have to think about the data collection from the beginning. And so this is kind of a good example of application of this. And if you want to go faster and not waiting for actual failures, you also need to, well, this time, in this case, you can use maybe outside softwares to do a physical modeling and create your own data and try to apply some fatigue prediction, for instance. The next one is about modeling the wear, well, not really the wear, but damaging of our conductors according to the power load. And the answer is we are able to model the temperature. We can calculate the temperature and the history of temperature of our conductors based to this and based to the wind that may cool down your conductors and things like that. And it's in that case, the actual aging is mainly due to whether you will overcome the material limits or not. Meaning, are you too hot or not? If you are too hot, then you will drastically reduce the lifetime. And I'm thinking about even months instead of years. But if you are below your limit, then regarding at least fatigue, you won't have any problem for that. Maybe you will have problems with corrosion. How many people are involved in this project? Well, there have been a lot of people working on that. We are, at least from my project I'm working on with Maxime, it has been almost 10 years of work with maybe 15 to 20 people involved, if you're interested.
Yeah, but 5 people, equivalent of 5 people a year.
Yeah.
But what is important, once again, it was we start on physical modeling, so it's something that you need to develop,
yeah,
and it will take time. And once again, here we are presenting some work which is done and ready to be used with RTE International. So it's really important, this kind of thing. So if you think of what you can do, which part of the project you will use, you can start with a small, as Julien Chazot said, you may have some advice on your data. It's a thing. And after this, you may want to put some physical modeling and so on, or you may want to have the big picture first, but you will have the expertise of RTE International and Eurobios for this kind of project. So it's time saving for this future project.
I believe the first important part is to assess the IT urbanism and situation and the main goals of the company. If it's, as says Maxime, the specific technology such as dynamic line rating, monitoring in substations, whatever, or if you have more long-term, planning objectives. So generally, when we have a request, we try to set up the things and to go on site for a first diagnosis of the situation, collecting the main goals and everything, and then we dive into techniques and starting to assess the IT systems and the techniques at the that are available. So this is usually the way we work. Depending on the project, we are able to mobilize between 1 expert to maybe 10 to 20 experts when it comes to big projects for several months. So it clearly depends. We have to exchange about that. Feel free to contact us.
Sorry, I need to interrupt you. So this is the end of our webinar. So maybe for the question that were, which one? We have a lot of questions that we didn't reply. So maybe we can come back to you by email with the answer. And we can also maybe share the presentation for the one who are interested in it.
Yeah.
So for today, we're sorry we need to finish now. So thank you everyone for this really good presentation and for the reply to the question. Thank you everyone for coming and joining us in this webinar today. And we hope to see you soon. Have a good day.
Thank
Thank
you.
you.
Bye-bye.
Bye.
Bye.